We're going to do some brief overview and intros. The question really is, what is low latency and who needs it? And you'll be surprised with how many of our customers use it today, and how we're doing what we can in our product set to really get it in front of people. Also, we'll go in depth with some low latency protocol discussion, and we look forward to some questions. We do have some polls that you can engage in. These webinars are the most fun when we get questions from people like yourself who sometimes even stump us a little bit. So really, if you have a low latency question about HLS, Dash, WebRTC, write it down. We'd love to hear from you. And it'll be about 30 minutes. We'll have, as I mentioned, we'll have Q&A, and then at the end, we'll have even more in-depth Q&A. So with us today, we have Charlie Good. He is a founder of Wowza. He is our Chief Technology Officer. So Charlie's got a ton of things to say. Barry Owen, VP of Solutions Engineering. And myself, I'm going to try to keep everybody on track here. I work with sales and customers every day. So thank you for being here. If you guys want to say hello, this is your time. This is it.
Hello.
Oh.
And Tim, also, could we
yes.
launch the poll if you don't mind?
Can we launch the poll?
Yes, we have a poll here asking what is your specific low latency use case, as well as which streaming delivery formats are you currently using?
Fantastic. Justin, thank you for launching that poll and not me having to launch the poll, because I would have been lost in webinar land. So please take advantage of that poll. We like to hear from you in these webinars. You see a graphic on your screen, and we're talking about streaming latency specifically. And this is a decent way to describe how long things take. I remember when I first got satellite television years ago, and I compared it to over-the-air broadcast, and it was like, 5-10 seconds off. Well, it's really the concept of what's happening now versus what's happening on the screen of somebody viewing the screen, viewing a broadcast. So here you see from gray all the way to green. If you just have standard latency, maybe you're using YouTube Live, you're using Wowza Streaming Cloud or Engine, some streaming service, it's not latency dependent. It's highly reliable, but it's about 30 to 45 seconds latency. As we tune these workflows, make the chunk/segment sizes shorter, use different protocols, we get into reduced latency, low latency, and near real time. So reduced latency, OTT providers, live streaming news and sports, a little more interactive, a little more real time. The idea is if you're watching a football game on a IPTV service or some type of live television service, you don't want to hear about the touchdown 30 seconds later. You might hear your neighbors across the street, shouting because they're watching it over the air or something like that. You want it to be as reduced latency as possible, the more interaction there is. And then it gets a little more interesting after you get past that 5-second point. And we put a little blurb in there that says typical latency for HD cable TV is about 5 seconds, which is great if you really think about it. But then you get into low latency where live stream games, esports, much more interactive, faster feedback needed from the audience. And down at the bottom, you see a lot of different options that start coming into play as far as protocol. Because over on the left, on the bottom, you see Apple HLS and Dash, and then you see tuned HLS and Dash, and then RTMP, which is the old standard. And then you have all these protocols, low latency HLS, CMAF for Dash, tuned RTMP. You can tell that we're doing a lot of work to really make this fast. And if you pay attention to that bottom third of the graphic, you can see WebRTC certainly leads on speed for low latency, ultra low latency. So we can get it up into that 1 second latency range. And that's where things really get interesting with ultra low latency, two-way web conferencing, telepresence. If I'm unfortunately injured, I want a doctor working on me remotely in near real time. I don't know about you. And then, of course, it's great to have IP cameras, PTZ cameras, if you're monitoring some type of crisis. We have customers that are a significant number of customers who use Wowza for monitoring emergency situations, even almost like a video conference with 911 calls. So there's a variety of needs for low latency streaming.
I think one important point too is, is that like a lot of this push is trying to get low latency streams into the browser. So there's plenty of methodology. I mean, this is Zoom's an example. Certainly, the other kind of more not webinar, but more communication type tools are certainly doing low latency. But a lot of that is accomplished in plugins or apps that are running on the local device. Where a lot of the push around low latency around is how can I get the same experience in a browser under the browser security, to all different platforms. That's the mobile browser, the desktop browser, browsers in in TVs and set-top boxes. So that's where a lot of this push is.
Definitely, you got to be able to view it, right?
Right.
So who needs the low latency? We've got a few use cases here. Pre-COVID, second screen experience. Betting and bidding. There's the Meekum auto auction. Video game streaming and esports, video chat. It's pretty easy to remember the traditional cases for low latency. Post-COVID, as we say, and that it's really been an issue in our industry, obviously, because of the virtualization of industries and professionals using technologies like Wowza and other technologies too to communicate with their employees and their customers and virtualize events. So that's where you have concepts like telehealth, virtual events, remote producers. It's amazing what some of these marquee, huge broadcasters are doing to keep everybody on the same page as they review content, keep producers, editors, directors, everybody on the same page. They have a tremendous need for low latency, and it's been awesome helping them with the really unique use cases they brought to us. And then infrastructure, that can be all sorts of things. We talked about it earlier, IP cameras, two-way communication. It kind of goes on and on. So there's a need, traditionally, I'll go back to that slide where, just betting and bidding, video games, these things need to be real time, but also some of these new use cases. And these are just 4 areas that we've mentioned. They get very, very specialized. So if you're challenged, if you need a low latency solution and you feel like you're out in the fringe, don't hesitate. If there is an opportunity for you to contact us at Wowza, we'd like to hear what your challenge is because we may be able to help you. All right, so we're going to talk about WebRTC. And I'm going to need some help from Barry and Charlie because these guys really know what's going on under the hood. So I'd like to kind of just go through these bullet points we have and then just let the conversation build from there. I'll just lead off. WebRTC is growing in popularity. A few years ago, we kind of laughed at WebRTC. You're just kind of like, oh, WebRTC, really? Maybe I shouldn't be saying that, but now it's obviously very prevalent. So WebRTC is growing. It allows for low latency delivery in a browser. To your earlier point, Charlie, gets us away from Flash. But it's limited in scale without actually leveraging your own media server. Use cases include remote emergency communications, personal video, a lot of what we talked about earlier. So WebRTC is a great solution for just getting that ultra low latency out there. Any comments, guys, just on these?
Yeah, I mean, I think originally, and it really started as kind of peer-to-peer, browser to browser, and it was kind of one-to-one. And that's the roots of kind of where it began. And it certainly has grown from there. And, and even some of the ways that we're trying to use it kind of bends the way that it was intended to be used. But what it does provide for you is like 2 important things. And one is a transfer protocol that's UDP based that now has a way to recover drop packets because it is UDP based. That allows you to do things that much closer to real time because you're sending frames and streams and audio and video frames like real time as they're happening, as they're being captured directly. And then the other thing is the playback mechanism that's in each one of these devices, browser devices, wherever you're kind of consuming that WebRTC stream. They're really tuned for low latency playback, meaning they'll speed up and slow down the audio if they fall behind or drop packets. They'll try to like gracefully drop packets and make sure the playback experience isn't bad. If you lose a bunch of frames and then all of a sudden they come flooding in, it'll play them quickly to kind of catch back up again. So like all those things are important because, again, live is live. Like you once you get behind, like you need to do something to catch up. So the player part of it needs to be tuned as well. So those are the kind of probably the most important 2 pieces that WebRTC provides as kind of tuned technology for that real-time experience.
It's a lot
Also
going
has
on there.
things
Zach.
like, security's built into WebRTC, right? Uses DTLS encryption. So, the packets are all encrypted at the data level, which is, and all that's handled seamlessly for you in the browser, which is nice.
Barry, what do you think about scaling WebRTC? I've wrestled with this. I mean, how many servers I should use? Do you have any just quick advice on that?
Yeah, I mean, so WebRTC is proving that it can be scaled, although it's probably always going to be a little more expensive and a little more complex to scale, because it is delivering, things frame by frame. It doesn't take advantage of some of the caching things you can do with HTTP based streaming, which we'll talk about here in a little bit. So, you're seeing more and more companies come out with scalable WebRTC solutions, including Wowza. I think you'll always see, though, that for super large events and very, very massive numbers of audiences, you're either going to have a hybrid model or you're going to really want to fall back to a traditional HTTP streaming. You will sacrifice some latency. Most likely, though, you'll get a better viewer experience and you'll be able to scale more cost effectively.
Yeah, I'm seeing that with live event. I was recently speaking with an EDU, a large school. They're experimenting with Wowza and kind of thinking about doing that hybrid where X number of people are interactive, but then N number of people are watching it on HLS. So the nice thing about having a media server is you can do both, right? You can have people log in as
sure.
M3U8 or whatever.
I mean, they're kind of, you do think of those. I mean, they're kind of a weird name, but they're kind of lurkers, right? They're people that are watching the higher latency stream, but they're not necessarily going to participate directly in the, whatever the event is, and that's fine. But that's an excellent way to scale, right?
And for large events, that's probably the bulk of your audience, honestly.
Right. And so we're seeing a lot of that around of those types of requests, like the hybrid. I want a handful of people that may participate in my event. They may even be pulled into the event, and their audio is going to be then retransmitted as part of it, right? But then the rest of the people can be higher latency because they're just viewing the output or outcome of that shared experience for the people that are on the low latency portion of it.
I think we need to ask our product team to put an API request in for participant versus lurker metric, because I think that's a really good point. It's obvious that people have to do that, and a lot of people do just passively watch, so it totally makes sense. Before I dive into this slide, Justin, I want to just pause for a second. Do you want to go over some of the feedback from that poll, or do you want to wait a second on that?
Well, actually, I can certainly show the poll if you'd like to see it, but we do have a number of questions that have come in, some of them relating to your discussion here on WebRTC.
I think we're in the topic right now, good enough to field a couple questions. Why don't we see what we got?
Okay. Well, John R is asking, what is it about WebRTC that allows it to actually be so much faster than other webcast protocols?
UDP. So Charlie talked about that a little bit.
Yeah, I mean, it really is the fact that it's UDP based helps, right? Like the fact that you're sending frames frame by frame, they're being delivered immediately. You don't have the overhead of TCP, which kind of is a bidirectional connection based mechanism. If packets don't make it, they get dropped, and that's just kind of part of the way UDP works. So if you flood over and beyond what your bandwidth available is, some packets will get through, others won't. But on the other end, you can either request the packets that didn't come through, or you can reassemble what you have and play it back in the best way you can. So it really is a kind of fire and forget protocol from a sending perspective. Like whoever's sending the video to the consumer is sending those frames and forgetting about them, just sending. And so that since there's no necessary acknowledgement back, in the kind of normal operation, then those frames just flow directly into the player and are played back immediately. And as long as there's no packet loss, then that process happens, as fast as those electrons can travel the line. Like it's that fast. So I think it really is the fact that they chose UDP as the base of WebRTC. You can also do it over TCP, but for the best low latency experience, you're going to want to use UDP.
And it
provides the latency.
And that's a bit of a double-edged sword with WebRTC. It's the reason that you get such the low latency, but it can also cause some of the quality issues that, you have to decide what's more important to you.
Good question.
All
Yep.
right. Well, unfortunately, most of the other questions are related to different subjects, so I don't want to get into them. Although John said, got it. I thought I heard it said that this WebRTC somehow covered packets earlier, and so I wondered why that was relevant. Oh, and I have another one that came in that is asking, Mike is asking, what encoding does WebRTC use? Is it, I think he means what codecs does
What
WebRTC
codecs, yeah.
use? Is it H.264, HEVC?
It was the initially spec for WebRTC was VP8. Browsers, most browsers, if not all browsers now, Charlie, I think include support for H.264. And I think you will continue to see new codecs supported in browsers as we move forward.
So VP8, VP9, because usually both of those are
Right,
supported
VP9.
different ways. And then, yeah, as well as H.264.
Awesome. Okay, and if you would like, I'm just going to share the results.
One other question. Oh, sorry, while we're on that subject, the audio codec with WebRTC can be a gotcha for people. So, WebRTC uses Opus as its default audio codec. So when you do hybrid workflows, you do have to transcode audio, typically either from AAC to Opus or from Opus to AAC. So that's just something to be aware of on the audio side.
Awesome. And Tim, you had asked to share the poll. I just wanted to show it to everyone so they could see. Definitely have a lot more people here on live events, and seems like most people, which is to be expected, are using RTMP and HLS as their protocols.
Yeah, so the results I see, it looks like live sports, video chat, and live events. I'm just taking a quick glance at it. I don't know if we have to scroll this. Oh, okay. Yeah, so on the first one, looks like live sports and live events are specific use cases we're interested in here, and that aligns with who we've seen adapting low latency and ultra low latency protocols. Live events are a huge challenge, and ultra low latency, even in a hybrid mode, is very useful for a live event. I worked with another broadcaster recently who they needed just a low latency. Remember that chart I had up earlier? They were actually on the left side of that 5-second mark that we decided, but they have captionists that are remote, right? You can't necessarily have a captionist in a venue these days. So we set up a WebRTC stream so that they could be in their remote location, and they were getting around, just under a second. And so they're captioning and shooting that back into Wowza, and then Wowza is able to deliver the captions in like a CEA 608 format, real conventional. So there's a lot of use with live events, creating that interactivity, getting that spontaneity between the participants, but at the same time, having conventional play out over LL-HLS. So that's really, really interesting. Do you guys have any comments on what's in the poll so far?
No, it makes
Anything
sense. I mean, it certainly kind of covers a lot of our customer base, the folks that are interested in using us. I mean, that's where a lot of the use is, which is great.
Definitely. Well, let me be a good moderator and bring us back to center, and we'll start pounding through these slides a little bit more.
Actually,
Justin,
before you do that, Tim, what I'd like to do is 2 things. I'm going to launch the second poll that's asking the questions on how much latency do you hope to achieve in the future, and which low latency streaming protocols are you interested in learning about the most? And while we do that, I have one more question that just came in related to WebRTC. Oh, 2 questions, actually. Mike said, do you ever see SRT replacing WebRTC for UDP for low latency use cases? That was 1.
Barry, you and I have talked about this a
go
little
ahead.
bit. I would love for you to pick this one up.
Well, the biggest problem with that is there's no direct way to get UDP into a browser. WebRTC is a complex stack that surrounds it and happens to enable UDP within the WebRTC protocol. So potentially, you could fire up a WebSocket and do something like that and send SRT, but there's a lot of lifting there, and there's no standard around it. And I think that's probably the biggest constraint as far as that goes. I do think SRT may be a viable option on a mobile to mobile scenario, or 2 mobile devices where you have control over the stack via an application. And SRT is certainly viable as a contribution protocol. Oh, Charlie, you probably have an opinion on that as well.
No, I totally agree. Like on the contribution side, where you're outside of the bounds of a browser, then for sure, SRT is a viable option and is going to be used, in many workflow today. Like it's available today. It's a great way to do it. It's low latency. It's a reliable way to send UDP. So it gives you the advantages of UDP plus the reliability, plus the security, plus. I mean, it really is a good way to do it. It really is a matter of, can SRT get into the browser? I think more likely is Quick, just because it's Google backed and already pretty close and inside of Chrome and other browsers. Like there's a very good chance Quick will be there, and if you go dig into the source code of Chrome, you can see things like Quick RTC. That makes it seem like they're they're certainly thinking about things like that.
Well, and potentially Quick could really be just the TCP replacement for video, right? I mean, video streams leverage Quick entirely and skip the TCP stack altogether moving forward. So I think Quick is going to be very interesting as it kind of becomes more mainstream, and hopefully the IETF version of Quick and the Google version of Quick converge and become standardized.
All right, and we've actually hit a number of more questions about WebRTC. I don't want to hammer you with them. I know we got to keep moving forward. I'm going to ask one of these, and then I'll push the rest to the end. But one of them was saying, Jeremy's saying, they need low latency for live events on the production input side, but not on the consumer viewer side. So can WebRTC help with that?
Absolutely. That's exactly the workflow Tim was describing with the captioners, right? Those captioners could be producers. And, so you can have a low latency feed and get that feedback loop and then broadcast the result out over, either standard latency HLS or low latency HLS or Dash.
All right.
Some of it quickly, like some of it does matter your goal, like what you're really optimizing for. WebRTC isn't going to, like as a publishing protocol, isn't going to really optimize for quality. Like it's optimizing for low latency and delivery from the web browser. If you're really trying to optimize for quality, you may want to try to find an encoder that will do SRT. I mean, that will give you, that allows you to control the quality a little more. I mean, again, a clear cache would be a great way to do it because we also have adaptive bitrate encoding, which again will give you the lowest latency, enable you to use SRT, and enable you to get decent, really decent and really great quality over a low latency connection.
All right. Well, hey, I don't want to keep you guys from going to the next slide, so I'll leave it back to Tim. Tim.
Honestly, it's much more interesting, I think, to hear what the people are asking real time. So I'm glad you're injecting these questions because it makes for great conversation. I've noticed we've hit on Quick a little bit, which is at the bottom of this list. But we were talking about, again, WebRTC. We've covered low latency. There is some device dynamics. We're hoping to see that it continues to broaden in compatibility. It's a little bit challenging to get WebRTC to play back on a mobile. It's open source and standardized. And what's the deal with this adaptive? I want to say ABR with WebRTC, but it's probably the wrong term. But guys, what's the deal with people asking for some type of adaptiveness on maybe contribution, but mostly on play out? How's that working out?
Well, it's handled in contribution. WebRTC typically is a variable bitrate encoding that can effectively modulate on encoding. The way I understand the playback part is it's more of a simulcast where you offer things and you have to have logic in there to be able to pick the right stream for the available bandwidth on the playout side, not as dynamically switching as you can with HLS or Dash.
Yeah, so one-to-one, it certainly can modulate the output from the publisher to the player, real time to make sure that works. It's when you're doing one-to-few, one-to-many, where you don't want to take the lowest common denominator of the people that you're publishing to throttle the quality of that stream. So in those cases, yeah, I mean, you probably end up in more of what we call a multi-bit rate scenario where you're not automatically switching, but you may be switching up front based on some sort of bandwidth test, or you're allowing the user to switch between different bit rates based on the quality of their stream that they're getting back. And like ABR is a little tougher. It's tough to know. It's easy to know when to switch down. It's tough to know when to switch back up when you are trying to do something real time and it's hard to measure.
So in WebRTC, is there an ABR capability, or is that something that's still in development?
One to one, there's modulate.
Right.
One to one, it can affect. They can affect each other. A player can give feedback to the publisher to tell it to switch bit to change the bit rate in very kind of incremental ways. One to many, like it's much more difficult, and we don't certainly have a solution around ABR for one to many WebRTC.
Yeah, and that was kind of my question. I'm visualizing how, you know, we provide a manifest file that has different bit rates in it for HLS example. I was just curious if that might be something that maybe someday with RTC.
You can advertise multiple availabilities in the SDP exchange, but the player isn't going to probably switch those midstream, right? Because there may not be the right initialization data and things like that coming through. So it's harder on the player side to do that dynamic switching. You may attach to a lower one because you have less quality to begin with. It's less likely you'll switch up or down. It's possible, but it's less likely.
So could somebody put in their player a button that says high, medium, and low, and it could be something that the user could intervene with? Or is that too cheesy?
How it used to work. I mean, you can, right?
Yeah, presumably.
Yeah.
So a couple minutes ago, Charlie, you talked about stability, you know, particularly how it's just a one-way transmission basically with the WebRTC. I would assume that stability continues to be a limitation because we're just blasting all the data out there for the clients, right?
Yeah, except there are recovery mechanisms now where the protocol's grown, and I mean, it uses some of the capabilities of the protocol it's based on to do retransmission, right? So I think there is the ability, if you drop the packet, to request it and have it reset. And that's fairly new. Like, I don't think that was part of WebRTC in the past. So those kind of features are kind of coming into the protocol.
So it sounds like, you know, the continued maturing of WebRTC stability. I mean, of course, in the video streaming world, that's a monster issue. But it sounds like what you just said is, you know, it's getting better. So the stability is potentially improving. And then broadcast quality. You know, I've been impressed with people using 1080 with WebRTC. I particularly would lean towards a lower bit rate 720p kind of situation. But you know, what do you think about quality as far as, you know, what would you recommend versus what's the capability, you know, with the limitations of WebRTC?
You want to go, Barry?
Sure. Certainly there's the potential for quality there. There's just a lot less control. So, you know, when you have a professional encoder like the Clearcaster or something else, you can very finely tune your encoding parameters for optimizing quality versus bit rate, you know, determining your proper keyframe intervals and things like that. You have a lot less flexibility with WebRTC with that, particularly, you know, if you're setting up in a browser, it's going to, certain browsers on certain platforms are going to limit what it's able to do because it understands that the horsepower of that machine isn't going to be able to keep up. So there's definitely a lot more limitations and a lot less, I would say, direct control.
Sounds like you really need to know your audience when you're choosing to go high on WebRTC.
Well, and that's, you know, you can mitigate that, right? So let's say you're doing a workflow where it's an RTMP in, WebRTC out, right? So then you are controlling your encode and controlling the quality of what comes in, and then you're delivering that as WebRTC out for low latency.
And then we talked a little bit about ABR. I got out of order, but tell us a little bit about these codecs, AV1, HEVC, and Quick. I know you'd mentioned Quick, Charlie. Any just future predictions, codec department, or just any prediction in general that we may have missed? Anything on WebRTC that you might be able to share?
I mean, I would say like AV1 is a very high complexity codec, takes a lot of kind of CPU power to generate a AV1 stream. So I think, you know, there's a point of catching up. So the hardware needs to catch up, and the optimizations of the codec on the encoding side will need to catch up to where it would be a viable option for WebRTC. But you could certainly see it in the future, and you could see the amount of optimization that's happening over time for that codec is pretty incredible. HEVC, I mean, then you start to get into licensing issues with HEVC and trying to get it into a browser. So I think, again, I don't want to, there's a whole war around that, but like I think that's a little more difficult as far as how do you get that into a browser. Quick is transport, right? So it's more replacement for kind of raw UDP. And that's well underway in different ways. There's a spec on, standardizing that and getting it into browsers. And I think it's a big part of HTTP3. So certainly as a reliable method of sending low latency streams similar to what you can do with SRT, I think Quick will be a viable option in the future, and that seems to be heading that direction.
Very interesting. Justin, you got any tasty questions for us?
I've got plenty of questions for you.
Why don't you throw one out?
One thing I did want to do, somebody had asked if I could share the results again. So I'm just going to reshare the last poll results. I think they were interested in the fact that over 85% of the people were looking to have a sub 3 second. And I say that because if you look at sub 1 second and add that together with sub 3 second, that's 85% of the people want to have a sub 3 second latency when they're streaming. And it looks like they're back and forth between WebRTC and low latency HLS. I mean, certainly low latency HLS isn't out yet per se, but those are the big interests there.
So I think,
sorry, go on.
Well, it's interesting, right? So on the latency part, sometimes I kind of feel like, if you ask people if they need low latency, it's kind of like asking people if they like ice cream. So, well, of course, I need the lowest latency I can get. And the real question is why? And what is it you're trying to serve? Because, if you're just trying to match broadcast latency, sub 5 seconds is probably more than adequate. You'll get a very good second screen experience. Everything will be in sync and life will be wonderful. As you drive the latency down, there are costs. And you have to understand if those costs are worth it to you. Now, we had a customer that I always like this story of, we had a customer that does dog racing, and, for every second of latency he can drive out, he makes like tens of thousands more dollars on each race. So absolutely drive it down as much as you can to where you can, barely stand it and the quality is still reasonable, and great, you're making more money, or you're playing more card hands in a day. So there are very good reasons to drive it down. But they're also
my favorite part of that story with the dog racing one is normal latency for HLS means that the first frame of video happens when the race is over.
Exactly, right? The 30-second race.
Dog races don't go very long, so yeah, it doesn't work.
And then, as far as as the protocols part of that, right? I mean, we should probably move on to speaking of the other protocols, but again, it's all cost benefit. So, being able to play the thing back everywhere, being able to scale it easily and things like that. So with that segue, I'll let Tim take over and we'll drive to the next one.
LL-HLS, low latency HTTP live streaming. It is a very hot topic. I think we're right on the edge of getting this out into a public release. And I think we should spend obviously we're going to spend some time talking about it. I've been, Barry, you had mentioned earlier, and Justin, you had showed the slide where people either want what low latency HLS is committed to providing, or they want that sub 1 second, that ultra low latency. I'm having these conversations with streaming professionals where they're really looking forward to a low latency HLS, because eventually you're going to be able to scale it like you can scale a standard HTTP stream today through a CDN. So it's coming of age, and there's been so much work over the last 3-4 years with using WebSockets and using different protocols and tweaking HTTP this way and the other. And now here we are with a spec that, as it says in the slide that I've got up here, it's an extension of HLS. So it's going to have the same simplicity, but it'll get it down around 2 seconds. It's coming from Apple. Apple designed, they mandated Apple HLS in the beginning, which put us at a disadvantage for latency, but an advantage for stability. And now they've helped us design, and the entire industry is working on it to get decreased latency at scale. So you can see that it deals with HTTP2 push. And I really want to let Barry and Charlie kind of expound on this, and then, we'll talk about some of the new functionality. So let me step back. Just introducing the topic here. Tell us a little bit about just a little bit of tech, just a little bit about what's going on under the hood with low latency HLS, and let's see if we can develop this topic a little bit. Barry, what are you thinking? Or Charlie,
Oh,
go ahead.
Barry. I'll let you go.
I was going to let Charlie go first.
No, go.
One of the most interesting things about low latency HLS to me is that, it's completely backwards compatible, right? So you can spit out a low latency HLS stream, and any player that can currently play a regular HLS stream should be able to play it. Now, it won't play it with low latency unless it's got optimized code in there for that, but it will play. So you don't lose your device compatibility across the billions of Apple devices out there. And as you see from the poll, the bulk of people are still using HLS, and a minority of people are using Dash. So, Dash may have been a little bit of ahead in the low latency HTTP streaming protocols, but Apple's come on strong. One of the nice things about what happened here is, Apple came out with a spec. It was proposing some things like HTTP push and things like that, and they listened to the community. They listened to the CDNs. They listened to the people in the video community, and they revised their requirements to make it a little less onerous for CDNs and streaming servers to be compliant. So they relaxed the HTTP2 push requirement, and some other things. So that was promising, is that they weren't just shoving this directly down everybody's throat, and they listened and they made some changes. So.
See, it's funny. I like the history behind that, because if you really look back, like what really happened, right, is that the king was Flash, right? And so Flash was the way you played back media, whatever it was, 5-8 years ago. I don't know how many years ago it is. I don't keep track of time. But anyway, some time ago, you always used Flash to play back media, RTMP playback. And that meant things like Wowza Media Server and Flash Communications or Adobe Media Server had to run on the edge. It was kind of expensive to run those pieces of machinery on the edge. They certainly didn't use standard HTTP protocols. They were harder to scale. Like, you had to pay licensing fees and so that was the way you delivered video, right? Was using RTMP, whether it was high latency or low latency. But the advantage of that is it could be low latency, because you had a media server that could send things frame by frame, that enabled you to do low latency video chat, sub 2 second type of applications around streaming, as well as media and entertainment, where you were able to set your buffer to a larger value and get higher quality, more robust streams when you didn't care about latency. So then, kind of Flash started to die off, and there were choices made, certainly by Apple, to not support Flash. And then Apple HLS was the outcome of that, of like, here's how you do media and entertainment-based streaming. And the answer was HLS. Again, latency very high, 30 seconds, 40 seconds, maybe tuned down to 8 or 6 or whatever when you got down into small chunk sizes. But clearly there was a hole. Like, now there wasn't a way to service that 1 to 5 second market, which, as you look at our poll, everyone wants to be somewhere in there. And so this is the answer to that, right? Like, in some ways we took it away with Apple HLS and Flash going away and RTMP as a playback protocol going away. And this is bringing it back, saying, yes, there is a use case in the 1 to 5, 1 to 3 second latency space that needed to be filled. And it was obvious, like, you could see it. As soon as the HTTP streaming protocols came, everyone that was doing low latency stuff and saw Flash was going to disappear was like, what's the answer? And this is the answer, along with low latency Dash, right? Like, I think both are answers to that question. So I think it's in some ways, it's a long time coming, right? Like, it has taken a long time to get this back, where now I can service more of those low latency use cases like we highlighted at the beginning of this presentation. It's not a rant. That's how I look at it.
Actually, Charlie, it's funny as you tell that story, you could fast forward that story to now, because I have some of the same concerns with WebRTC as I would with RTMP. Right, it requires a media server on the edge. It delivers video frame by frame. It's a little more expensive to scale. It'll be interesting to see where all that goes.
Right. Yeah. So I do think for this 1 to 5 second streaming, like, it feels like the right thing, right? The other thing is, the other important points in most of those type of low latency applications around video are they need metadata as well. And then that metadata needs to be synced to the stream, and both Dash and tag it to frames, tag it to times, and make sure that those metadata events are available. And so that's another important piece of the overall lower latency solutions.
Yeah, that's a really good point, Charlie. We find that, you know, a large portion of our customers, certainly that used our own proprietary ULL solution in the past, you know, it's really the technical implementation of it that, yeah, for the super technical people who want to go implement a player or who want to go really understand how this works under the hood, those are all relevant. For the people to consume this, let us worry about it. We'll worry about the sport. We'll work with player vendors to support it. That may be something you never have to know.
Well, yeah, that's our job as a media server, right? To handle these things so that you just kind of hook up your encoder and probably deal with a few properties and implementation steps. And theoretically, you bring a player in and it just works, right, guys? So hopefully that's where we end up. Future predictions.
Quickly,
go ahead, Charlie.
Quick,
Yeah,
sorry, I always have something to say. So
absolutely.
the other thing is that it does, those features do in most cases require some changes, modifications, tunings to what's going on in a CDN or on an edge. Like, and so that's what's happening now, right? You certainly, there's what we do with, well, as a media server, to take in any kind of stream and turn it into one of these low latency HLS streams, you know, and there's a chance you'll just deliver directly out of our server, which is great. But then you want to go through a CDN, then there is things that need to happen on the CDN side to enable the features in that list, right? And so we need to make sure, as the origin for a particular stream, that we're able to send that stream in a low latency fashion to the CDN, and they need to take the care to be able to take those chunks, the pieces, the parts, and be able to present them to a player in a way where they can utilize these types of features.
It does not sound like a trivial task, being a CDN and getting all those fast moving components in place. It sounds like that's going to be probably one of the most significant parts of this move to LL-HLS.
Yeah, but that works well underway. Like, that's the nice thing of it being a spec. Everyone knows what the spec looks like, and they're all racing to get those kind of features implemented. That's a good thing.
And some of the CDNs were well on their way by, you know, Dash did have a bit of a head start here, right? Low latency Dash, and it implemented some standardized things that, you know, CDNs started to work on, and they can leverage that for this work as well.
And the spec did twist more in the direction where people were going with Dash,
absolutely.
which made it nice, so that I think it's starting to unify over something that's a little more simplistic.
Yeah, and I'm looking at this list here. You know, Barry, you touched on compatibility. We're certainly talking about HLS, so it is still HLS, simple and robust. You know, as I understand it, if your device or if there's some dynamic that's preventing you from playing back the sub segments or the low latency HLS, you can actually revert back, right, to just a regular HLS playback, which is amazing from a backward compatibility standpoint. You know, new and in flux, obviously it's, you know, this thing's going to get better as time progresses. We've hit the CDN item, you know, and Charlie, that's a fantastic point that it's a spec and they're working on it. You know, there are reliability, resource availability concerns, but I mean, who doesn't concede that with an ultra low latency stream? I mean, there's going to be a blip here and there, right? And we'll probably be better at handling that as well. You know, I know when we let off on low latency HLS a few minutes ago, Barry, you talked about the billions of iOS devices. And that'll drive greater adoption. And that's true. And this is being adopted too, of course, by browsers and media players, right? This is something that's really coming of age, so to speak.
Well, yeah, I mean, we're working with player vendors to support this. You know, we have demos we can do with TheoPlayer who, you know, leverage streams from Streaming Engine. And in some cases, we've even seen some preliminary stuff going through CDNs that we've been able to play with. And then, you know, as support in iOS 14, both in the browser and in applications on iOS devices, obviously that enables many things on, you know, between the whole anywhere in that ecosystem.
I was thinking about bringing up the TheoPlayer demo for ultra low latency or low latency HLS, but I know better. And I don't want Justin to have an anxiety.
Yeah, I don't know how
attack,
you can do a low latency demo via a webinar, via a video. So
it's a little
good luck with
cowboy
that.
for this morning. Justin, how we doing on questions with LL-HLS before we jump into Dash? Anything interesting?
I have plenty of questions for you. Absolutely. Not sure if we even need to talk about Dash based off of the level of interest shown in the last poll, but let me.
Well, I would say that. Yeah, go ahead.
Sorry.
Okay. Yeah.
Am I waiting to answer to ask some of these questions? So just to verify, Roger wanted to verify at least. Will we be supporting time metadata with low latency HLS?
Certainly eventually. I think our current implementation does not, but that is something that's on the roadmap to fill that hole.
Okay.
Great question.
One person had a question going back to WebRTC. There was a question about costs. You had talked quite a bit about costs, and they wanted to get a better idea of how significant these costs are, as they think, say, are they related to being able to scale, or is it stability issues, or is it mobile access issues?
I would say scale and access. So, right. So, there are a handful of smaller vendors that are doing WebRTC CDNs. What you're going to find is, in general, your cost per gigabit for streaming WebRTC at scale is going to be significantly higher than your cost of streaming an HTTP format. With an HTTP format, you can stick a cache on the edge. It can be a relatively dumb cache running on commodity hardware and serve tons and tons of people. Going back to Charlie's story about RTMP, WebRTC requires a server on the edge. It requires something that's more intelligent, that uses more compute power, and is more expensive to scale.
Awesome. Another question that came in, and I'm going to make this sort of a two-part question, or not a two-part question. I'm going to merge these together. Some people were asking about basically what recommendations do we have for players that do ultra low latency or use ultra low latency. And another person had a question of, does AWS CloudFront CDN currently work with ultra low latency. What am I saying? Low latency HLS for with Wowza. So we have a lot of questions relating to basically, what companies do we know as part of the whole process of, player and CDN are going to be able to handle low latency HLS?
Player side, like we're working closely with Theo Player, correct?
Yeah, we're working with Theo Player, and you'll see other player vendors, Video.js, and even some of the things JW Player, I'm assuming. Everybody's going to be working on it. I don't know of a CDN that's released anything. Perhaps Akamai has something you could latch onto, since they did release Dash low latency via their CDN. But I don't know of a CDN that's basically finalized low latency HLS yet. And I have very little visibility into what CloudFront is doing. I'm assuming they're working on it. I do know that Fastly is working together with us and Theo to get something working from end to end. And like I said, I think, Akamai is probably fairly far along in their implementation as well.
Yeah, that's where I'd look.
And I know I'm forgetting a ton of other CDNs that are probably working on it, and I apologize to all those CDNs, but I don't have that visibility.
All right. That all being said, we keep talking about the low latency and comparing WebRTC to low latency HLS. What are the latency numbers that we're seeing so far for low latency HLS?
I mean, I think for low latency, we're in the 1 to 3 second range, right? Like that we're down in that. It's not sub-second. I mean, it's more in the 1 to 3. Like that's where that sits, which covers, like, again, looking at that poll, which is very interesting. It covers the space, the edge of the 1 to 5, or but certainly not the less than 1.
Okay, thank you. And Rob has his basic question is, he wants to know extra overheads and resources look like for low latency HLS over normal HLS deployment. He's stating they use HLS to deploy situational awareness to police officers on the ground attending calls, and their lowest latency is super important as it affects their decision making, and they're currently using HLS tuned down to about 6 seconds. So low latency HLS looks very interesting, and they are waiting to see a complete integration into Wowza.
So when you look at what a CDN would need to do, so with regular latency HLS, like an encoder, or even, I mean, Wowza Media Server as an example, or Clearcaster, 2 examples of how you would get the stream into the CDN, you'd be pushing chunks, pushing fragments, CMAF fragments, and new playlists into some sort of caching mechanism. Either you're pushing them to the CDN or the CDN is pulling them. And the difference with low latency HLS is that now, as you're pulling them or they're being pushed to you, you need to be able to make them available for streaming immediately as they're being ingested, where that wasn't necessarily needed before, right? So that's one piece where that machinery is most likely more expensive to run and heavier load on a caching server to be able to receive and send at the same time. So that's one part. And then the other thing is the low latency HLS spec. One of the other pieces that's key in getting the low latency is the blocking concept of, I'm going to request a playlist and it's going to block for a while so that I get the most recent update to it, so that I don't have to continuously poll, and because you're going to lose time polling. You know, you'd rather have it block and wait and give you the answer when it's immediately available. And again, that machinery means you have an edge, an HTTP edge in some CDN that's now having to hold on to a TCP connection and then respond with an answer over time. And so again, now you have that thing holding on to more active connections at a time. And my guess is that's going to present more load for an edge. I mean, none of these things are significant. I mean, they're not like to the level of SSL or like other things, but they're certainly going to probably generate more load. Like how I mean, and the other things, we don't know how CDNs are going to price that capability like that. You know, it may not scale directly to the overall load on an edge, but certainly those are 2 kind of pieces of the machinery that are needed that will probably cost more money and be specialized.
Awesome. So basically at the end of the day, until all of the parts of the puzzle are finally available, we're not going to really have a definite answer to that.
The other thing to note is in the case you're detailing, it might have been a small number of users, so you may have been streaming directly from the origin. So you will see the same things Charlie, you know, identified there. You'll see them on the origin too. You'll see more playlist requests. You'll see the blocking. You'll see the holdback and things like that. That will generate a little more load on your origin server as well if you're serving directly from your origin. You know, and that may translate into enabled, you know, instead maybe previously you're able to serve 1,000 people from your origin. Now you're maybe going to serve 800. So, you know, you're going to have to look at that. But other than that, particularly in that case, if you're ingesting, serving out low latency HLS to a variety, to a small group of people, going from, now you're going to go from 8 seconds down to 3 seconds. It's really just going to depend on the load you want to test it, but you know, you may not see much impact at all.
Okay. We also have a roadmap question here, basically asking, is low latency HLS going to be available in Wowza Streaming Cloud?
Yes.
Yes. Yeah. So yeah, I mean, that work is,
I'm not going to say
work is underway. Like in fact, there was a meeting this morning on it. Yes, so that work is underway. Just trying to figure out timing and when things are stable. I mean, there's a lot going on, right? We're waiting for iOS 14, you're waiting for that. So it's just a matter of timing of getting all the proper pieces of technology tested and reliable and then put out as a service.
Okay. And that being said, someone else was asking, and I don't know how much this relates to maybe being able to use WebRTC or low latency HLS with it, but Marcus is asking, will we ever be offering our own player again?
I don't think we're planning on doing that, are we, guys? We're really leveraging Theo Player now. From what I understand, they have a really cool SDK. Like you can do so much with their player. I could be totally wrong because I'm not sitting in on all those meetings about where we are with our product strategy. But sounds interesting. What do you think, Barry? I can see your wheels turning.
Well, no, I mean, we want to work with all of the players in the ecosystem. When we, Theo reached out to us and we started to work on this low latency HLS with them, and they were well underway, and I expect other players to follow suit. Yeah, I don't see a compelling reason for us to go back and recreate our own player and compete with companies who are basically solely focused on creating really good video players.
All right. Some of these questions, I have to say, are relating more towards, the hopes of low latency HLS in the future. So I don't know how much we can really answer things like how it's going to integrate with CloudFront at this time. I think, though, there are a few questions related to our own product, and I just want to reference those right now. Someone else was noticing that in their earlier test with Browser Streaming Engine, they were seeing significant CPU usage when having multiple WebRTC sessions simultaneously. And they wanted to know, what do we think that causes the CPU?
Charlie fixed that.
Yeah, I think we did fix that. So I think there are newer releases of Streaming Engine that have been addressed on WebRTC performance.
Okay. So Bo, I don't know if you're using the most recent version. I would definitely suggest you upgrade. Another question someone was asking, Higor was asking, how much approximately WebRTC could be faster? How much, I guess they're saying, how much faster could WebRTC be than RTMP?
I mean, I would say, RTMP ends up in the 1 to 3 second range for latency, where WebRTC pushes you down, below a second. So I think that's the difference. Like if you're in that 1 to 3 second range, 1 to 5 second range, like RTMP is great, TCP based, and it has the goodness and the badness of TCP. But I think that's where it sits, and then WebRTC sits below that.
Okay. I'm going to just ask 2 more questions here because I see we're down to the end of the wire. One of them is just maybe we can answer, I guess. Mike is saying, Mike notices that when he uses YouTube for auctions, he's seeing a less than 3 second latency with them. And he wants to know if we know, is this like a form of HLS, or what exactly are they doing to reduce latency?
There's information on the web that says that they're certainly doing things with Chrome and Quick and different delivery, and as well as they're playing with AV1 and VP9 because they both came from Google to get around tuning video quality in low latency. So certainly, I don't know exactly what they're doing, but I know they've run a ton of experiments, and they're delivering. They certainly in the past have delivered a lot of their traffic over Quick, which again is UDP based with recovery.
Right.
So I think that may be where they're getting some of those lower latency numbers, but I don't know their exact tech.
And they have, it's worth noting that, YouTube owns their own CDN. They have a lot of control end to end. So, and typically they own their players, right? So they have a lot of control over the stack and maybe doing something that is a bit opaque. If I had to guess, it's probably Dash-ish, but who knows?
Right.
It's not a default setting, so you have to actually, when you're
No.
creating a stream in YouTube, tell it to be ultra low latency. So don't be alarmed if you just do a standard YouTube stream and it's about like HLS.
All right. And the last question I'm just going to ask, because we do have a lot of other questions, but I know we don't have any more time now. The last question is, we have one person that currently uses Browser Streaming Cloud. They get about 15 to 30 seconds of latency, and they want to know what they can do to bring that latency down. Now, I know recently I've been streaming from WebRTC to HLS, and I still see about maybe 9 seconds of latency. So I don't know if that's the best.
Yeah, you can go into cloud and you can tune your chunk size down to 2 seconds, and there's a low latency option, and that's probably about as good as you're going to do for now. And that'll get you in that 8 to 10 second range most likely.
So is it just that checkbox for tuning that latency down, or is there something specific they need to do?
Yeah, I mean, cloud delivers streams via HLS, so standard latency HLS currently. So the only way to really tune that is by lowering your chunk size.
And then you would want to lower your keyframe interval on the encoding side to like either 1 second or some increment of that, like half a second or a second, so that then we can take advantage of it down the line.
All right. Well, thank you for that. Sorry to interrupt you for so long, Tim, but definitely there are a lot of people with a lot of questions here, and excited there are some very smart people to answer them.
Well, I said in the beginning, I was hoping that we would be able to bias towards some questions. We didn't get a chance to talk about Dash and CMAF and some of those dynamics. Maybe we'll speak of that in another medium or in another webinar someday. But I think this has been really interesting. I have learned a lot from being on here with Barry and Charlie today and reflecting on the questions and topic. We're here to help you. If you would like to speak to someone about Wowza, you see some email addresses on the screen right now. We will even answer the phone if you call us. You can hit our pricing. We've got technical support. In fact, we have had some support agents. I believe Jason Tukler is on, if there isn't anyone else on from our support team, answering questions in the comments, which is a wonderful part of these webinars. We're here really to listen and also respond as best we can, but we can't hit all of you. So if you have a question, it was interesting. Someone was talking about that CPU issue with WebRTC. We fixed it. We have later versions. Our support team is available to you. So definitely hit us up there. Get a trial. Try this out. That's one thing that's great about Wowza Tech is you can run it on anything. Run it on your laptop, run it on a cloud instance, run it on a Raspberry Pi. Get involved with us. We'd love to hear from you, but mostly I just want to say thank you to our panelists here today. Justin, really appreciate you taking care of the questions and polls. It's been a pleasure. And thanks to all of you for watching. Wish you the best of your day or evening. Take care.
Thank you. Cheers.
Thanks, everyone.